this is some CSI stuff, right? This is like from the TV shows, like there's a crime scene and there's some mystery substance sitting there. And you're the chemist, you're the forensic scientist. And you need to figure out what's that mystery substance, right? So you can like figure out who the killer was or whatever. Like this is legitimately like that CSI stuff where like you get some strange powder at the crime scene and then you figure out what it is. Here's how they do that. They take the mystery substance, they burn it, and they figure out what percent of the mass in that substance came from each element. What percent of the mass was carbon? What percent of the mass was nitrogen? What percent of the mass was oxygen? What percent of the mass was fluorine? They get all that. And then they do some stoichiometry. You assume 100 grams of sample and you work backwards and you convert the stuff to moles because moles is an amount. You can compare stuff when it's in moles. And then we can get the empirical formula for the substance and sometimes the molecular formula if we need it. I'll show you what I mean. Let's do an easy one and we'll call it a night. Let's say you do this. Let's say, you're working at a crime. Well, I'll tell you what, maybe we should do a tougher one. Do I have a tougher one in here? Nah, I just got that. Sorry. We'll do an easy one for tonight. It's getting late anyway. We'll do a tough one tomorrow night to start class. Let's say you go to a crime scene and there's some mystery substance there and you take it back to your lab and you burn it. And the computer tells you that substance was 22.59% by mass nitrogen and 77.41% by mass oxygen. We're going to figure out what that mystery substance was, or at least what its empirical formula was. Here we go. Give me 1 second to write those numbers down. We'll do it. And then we'll get you the homework and get you out of here. Awesome. Here's what you do. It's the first step. This is where things go wrong. This is the whole bread and butter of the entire problem. It's right here. When you get a percent composition problem like this, what you need to do is assume 100 grams. If I assume 100 grams, then if it's 22.59% by mass and I have 100 grams, then that would be 22.59 grams of nitrogen. And again, if I have 100 grams and it's 77.41% by mass oxygen, then in 100 grams, that would be 77.41 grams of oxygen. The first step is to assume 100 grams. The problem is I can't compare a mass of nitrogen to a mass of oxygen. Why not? Oxygen's bigger. Oxygen is a bigger atom than nitrogen. Look at it on the periodic table. Oxygen weighs more than nitrogen. Mass is not amount. Mass is not amount. So what is amount is moles. If I can use the atomic mass of nitrogen and oxygen and figure out how many moles of nitrogen that is, how many moles of oxygen that is, then I can compare. That's the next step. You have to turn these masses into amounts. So you need to find nitrogen on the periodic table, track it down. It's got an atomic mass of 14.01 grams per mole, 14.01 grams per mole. I want to convert this out of grams and into moles. So I'm actually going to divide that by the atomic mass of nitrogen. And I'm going to get moles of nitrogen. I'm going to get an answer here. We are just going to make it. I spent like an hour before class tonight planning tonight's lecture because I knew it would be so tight and reworking homeworks. And boy, am I glad I did that. Cool. Now, oxygen. We need to do the same thing. You got to track down oxygen. Oxygen's got a weight of 16.00 grams per mole. I need grams to go away, so I'm going to divide by that weight of oxygen. 77.41 divided by 16. That is 4.838 moles of oxygen. Have I lost anybody? First steps, assume 100 grams. I can't compare things till they're in moles. Divide each atom's mass by its atomic mass to turn it into moles. And now I can compare them. How do we compare them? It's very simple. Divide each one by the smallest number of moles. Let me say that again. We're going to compare them to each other to figure out their ratios to one another by dividing by the smallest number of moles. Now, in this one, there's only 2 atoms. So we're going to divide everything by 1.612 because that was my smallest number of moles. Obviously, 1.612 divided by 1.612 is 1. There's 1 nitrogen, 4.838 divided by 1.612. Here we go. That's 3. Now, sig figs don't matter in these problems because at the end of the day, you want whole numbers. Okay, because what you're trying to figure out is the ratio of nitrogen to oxygen and oxygen to nitrogen. Here's what we just figured out. There's 1 nitrogen for every 3 oxygens. Now, we usually don't write ones. That's my empirical formula. That's some CSI stuff, man. Okay, like legitimate. You burn it, you get the percent mass of every element that's in the sample. You assume 100 grams, convert those masses to moles, compare the amounts to each other, and that will tell you what the empirical formula of the substance is. Here's why that's important. The very last thing of the night. The substance might not actually be NO3. All that I know about the substance is that there's 1 nitrogen for every 3 oxygens. The substance could be any multiple of that. It could be N2O6. It could be N3O9. It could be N4O12. Any multiple of NO3 will have the ratio of 1 nitrogen to 3 oxygens. So I don't know the molecular formula, but I do know the empirical formula. What you would have to do to get the true identity of the substance is you'd have to actually weigh the substance using something called a mass spectrometer or a Muldi-Toff spectrometer, if it was like a protein or something. So here's how that works. You could get the mass, and let's say, for example, that you do this, and give me 1 second here. Let's say you get it, and it comes back that the molecular formula, the total weight of the compound, let's say the molecular weight of the compound is 248.04 grams per mole. Now, if I know the empirical formula and the total weight of the real deal compound, I can figure out what multiple I have to multiply this by to get the molecular formula. Here's all you do. Get the weight of the empirical formula. So 14.01 plus 3 times 16. If you go to the periodic table, those are the masses. 14.01 plus 3 times 16. That's 62.01. The empirical formula has a mass of 62.01. Our molecular formula is going to be some multiple of that. Divide the mass of the molecular formula by that empirical formula weight. Okay, 248.04 divided by 62.01. That's 4. I know that my real deal compound is 4 times this. So my real deal compound would be N4O12. That would be the true identity. I just made that up, but that's how those work.